Okay, welcome back. What we're going to be doing today is to talk about forces more generally. And what we've done before is talk about introduce Newton's second law, the net force equals to mass times acceleration. Generally, there's more than one force acting, so we can get into more complicated problems. Right now, for instance, I'm sitting here at a table. Obviously, gravity is pulling me down. There must be some force upwards to keep me from moving. And that would be the force of the chair that I happen to be sitting on. So there's two forces. So we have to talk about the net force, not just one. Okay. And what I want to do today is talk about the different types of problems that we can possibly ask. That's the question that you probably really want to know at this point: is what kind of force problems are we going to see going forward? Okay. So just to jump in, the simplest type is what you see, on where I am. What the mass on a horizontal surface? I'm sitting on a flat, presumably flat floor here. So we have a mass on a horizontal surface. That's the quintessential place to start. And as we go through these, they just get a little bit more and more complicated. That mass can be replaced by a car. I mean, obviously, pushing on a car is going to be a lot easier than pushing on a car without wheels. Okay, so all these things have more or less complicated um, examples that you could bring up. So we have a mass on a horizontal surface. We could take that surface and put it at an angle. So now we have a mass on an inclined surface. Put it on wheels is slide down. Put it on wheels, we can push it up. So these things just slightly more complicated. We approach them the same way. Okay. We can add a second mass. We can have a mass hanging by a pulley, hanging by a string over a pulley attached to the mass on the inclined plane. Okay. As we go through these, they just get more and more bizarre, more and more complicated. But again, we attack them in the same way. We don't necessarily have just one mass here. We have two masses. Okay, we can put a third mass in. We have the original hanging mass attached by a string over a pulley, attached to a stacked mass on an inclined plane. So we have two masses on the inclined plane. So now we have the force that the green is exerting on the blue, and all this craziness going on. Okay, again, we attack it in exactly the same way. To go into a different direction, we can have a mass that's going in a circular path. Imagine like a rock on a string, and we spin it around, so it follows a circular path. So here I have a mass on a table, say, and that mass is attached to the center of the table and follows a circle. Okay, we're going to attack this exactly the same way. All right, we can now take that mass, and instead of having it on a table, we can suspend it from the ceiling and have it going around in a circle, sort of like a pendulum, but in two dimensions. It's going around in a circle. We'll actually assuming that we actually go back into class, we do this with a flying pig. Have pigs hanging from the ceiling. Well, they'll be flying around. They'll be flapping their wings, flying in circles, and we'll be able to attack this in the same way. Okay. And here's my last one. We could take that swinging, hanging mass and attach it by a pulley to that stack of masses on the inclined plane. Now, all of these things can be made more complicated. I mean, the mass that was going in a circle, do we have some sort of central force? I mean, these are very simple things to draw on a screen. But I mean, that mass that's going around a circle can be replaced by, say, the Earth going around the sun. The Earth follows a circle as it goes around the sun, or the moon going around the Earth. All these problems are done following the same method. Okay. So that's what we will be going. And the real question at this point is going to be, well, how are we going to solve force problems? Okay. It turns out that there's going to be 6 steps in the process of solving any force problem. Doesn't matter what the force problem is. We're going to apply those 6 steps to each of the masses that you see. And the last slide that I had 3 masses there. We'll apply these 6 steps to the mass that was hanging off the table. Apply those 6 steps to the mass that's sitting on the slanted table, and those 6 steps to the mass that's sitting on top of the mass that's on the inclined table. All right, so it's just more of the same. and the beauty of this is it doesn't matter what the actual problem is, we're going to attack it in exactly the same way. Okay, those 6 steps are going to be explained more fully in the upcoming lessons. There's 6 steps. There'll be 6 lessons. They're going to be a lot of them are going to be really short. So stay tuned, and we'll get you through it. And again, the idea here is always going to be the same. So just learn these 6 steps. You see a mass and a problem, that's forces are acting on it. Apply those 6 steps. By the time you're done with applying those steps to all the masses that are there, your problem is, the solution to your problem is there someplace. Okay,